Hey there, everybody. Welcome back. We are going to continue on with 7.5 Systems of Inequalities. We explained the rules and did a couple examples last time. This will be 7.5 dB. Let's do some more. Our first example will have x minus 3y is less than or equal to 6, and 2x minus 6y is greater than or equal to 3 or 6. Okay, so for each of them, I think it's best to do get in slope intercept form. I will subtract 6x, or just x. Negative 3y is less than or equal to negative x plus 6. I divide by negative 3. When you divide by a negative, you flip the inequality. 1/3 x minus 2. Same thing with this line. I will subtract 2x. I get negative 6y is greater than or equal to negative 2x plus 6. Divide by negative 6. And that flips this inequality. And I get negative 1/3 x plus 1. So that was what was different about this one, is paying attention to the flips. Okay, so we have those intercepts. Let's find the x-intercept. X-intercept is when y equals 0. If I plug in 0, I got x is less than or equal to 6. So that's 6, 0. If I do this over here with the green line, I have 2x is greater than or equal to 6. So x is greater. This gives me my x-intercept over here is 3, 0. So my red line goes, I need another dash here. 6, 0 is here, and negative 0, negative 2 is here. Does rise over run get me there? Up 1 over 3, up 1 over 3, it does. This is a solid line. We'll do the other one. The x-intercept was 3, 0, and the y-intercept was 1. So does that get me there going from the y-intercept? Down 1, right 3 does. Down 1, right 3. Down 1, right 3. I'm going to rotate this to do the line. All right, so 0, 0 is not on either line. We can use that for a test point. In the original equation, 0 minus 0 is less than 6. That's true. So red will shade towards 0. And we test 0, 0 over here. 0 minus 0 is greater than or equal to 6. That's false. So we shade away from 0 on the green line, which means shading up. The region of overlap is the line from this point of intersection and that line to that point of intersection, and everything up in here is the solution. Okay. All right. So next problem. 4x plus y is greater than 4. Y is less than or equal to negative 4x minus 2. If I subtract 4x here, I see y is greater than negative 4x plus 4. So it looks like we have the same slope. These are going to be parallel lines. Y, X. So we'll make this one the red line. For the x-intercept, y equals 0. So 0 is less than or equal to negative 4x minus 2. I'll add 2 to both sides. Divide by negative 4. While the inequality doesn't really matter for finding the intercept, I still want to show it correctly. So this gives us a weird intercept of negative 1/2 0, fraction 1. That kind of sucks. I had y was negative 2 for the intercept, and negative 1/2 0 is here. Let's see, does that work? Rise over run would be negative 4 over 1 or 4 over negative 1. Negative 4 over 1 takes me down here, and negative 4 over negative 1 takes me right there, which does look like it crosses at that x-intercept. The slope intercept methods work pretty good. It's a solid line because it's got an equal portion. Here we'll find the x-intercept by doing y equals 0 again. 4x is greater than 4. I'm doing it in the first one. Divide by 4, I get x is 1. So 1 comma 0. 1 comma 0 is right there. And our y-intercept is 4. Does that work? Down 4 over 1. Yeah, it does. Down 4 over 1. Wait, down 4 over 1 is right there. So this line should be, these lines are parallel. It looks like 0, 0 is on neither of them, which is nice. So we can test 0, 0 in both. Test 0, 0 on this one. I'm going to do it in the original equation. 0 plus 0 is greater than 4. That's false. So this is my plus 4 one. This one is up here. This is the blue line. And so origin is right here. This was false, so we test on the other side. Or we place on the other side. We shade the other side. When I test 0, 0 here, I have 0 is less than or equal to 0 minus 2. 0 is less than or equal to negative 2. That is also false, which means for the red line, we have to shade away as well. And we have no interlap, folks, or no overlap. Did I say interlap? No overlap, not even the lines. There is no solution to this system of inequalities. Deep. Boom! We haven't had that yet, have we? Boom! All right, let's check out some more. X plus y is greater than 3. 2x plus 2y is less than or equal to 6. If I solve for x, I get y is greater than or equal to negative x plus 3. I do that over here. 2y is less than or equal to negative 2x plus 6. Divide by 2, and I get y is less than or equal to negative x plus 3. So it looks like we have the same line, folks. which makes this easy. I only need to find the intercept once. The x-intercept is, if I make y 0, x equals 3. So 3, 0 is my x-intercept for both lines. All right. And I got to slope. So my red line, I start at 3. I have an intercept of 3, 0 and 0, 3. The slope is -1. I can see that I would hit that spot. And I'll draw the line. And I'll test 0, 0. Test 0, 0. 0 plus 0 is not greater than 3. It's false. So I'm going to shade away from it. On this one, I had the same line. So, and it's an equal portion. So that's pretty important. And we'll test 0, 0 over here. Test it in there. 0 plus 0 is less than or equal to 6. That's true. In this case, we're shading downward on this line. So the regions of shading don't overlap, but the solid line does. So solutions to this system are on the line y equals -x plus 3, or x plus y equals 3. We want it in standard form. There's no overlap in the shading, but the lines overlap themselves. All right, one more. I know, but we got another scenario to look at. Nine y is greater than 3x minus 18. 2x minus 6y is less than or equal to 12. I'll do my red line over here. Y is greater than 1/3 x minus 2. My green line will be over here. -6y is less than or equal to -2x plus 12. Divide by -6. Y is greater than or equal to 1/3 x minus 2. It's the same line on both, isn't it? So -2, and let's see what our x-intercept is. If I make y equals 0, 2x is less than 12. So x is less than 6. 6, 0 is our y-intercept. I need another point. That's my x-intercept. If I'm doing rise over run, I got 1 and then run 3. 1 and then run 3. That works. 1 and then run 3. And I'll go back and go 3 that way. All right, so for the red line, it's dashed or dotted. And if I test 0, 0, I have 0 is greater than or equal to 0 minus 18. 0 is greater than -18, that's true. So we shade upward. On this one, we test 0, 0. And 0 minus 0, is that less than or equal to 12? Yes. It's the same line. This time it's solid for the green line. And it shades upward also. So here the solution is just the shaded region. Not the line. That covers pretty much a lot of the different combinations. That's it for this chapter. Peace.